Welcome to this explainer. Today, we're diving straight into Zhilin Yang's recent GTC keynote because, well, it was absolutely fascinating. We're looking at exactly how Moonshot AI managed to build a dramatically smarter model, Kimi K2.5. And the real kicker here? They didn't just brute force it. They didn't just throw a mountain of new computing power at the problem to see what sticks.
Which brings us to the elephant in the room. What actually happens to AI when the world just runs out of data? You see, the old scaling law, the idea of endlessly feeding an AI more and more text, has hit a massive, undeniable ceiling. So to squeeze more actual intelligence out of the exact same amount of data, the Kimi team had to get creative. They pulled 3 entirely new levers. Let's break them down.
Dimension 1. Upgrading the engine. Now, for years, the absolute industry-standard optimizer under the hood of these models was Atom. But Yang's team completely swapped it out for a new one called Muon. What Muon does is ensure that every single mathematical adjustment the model makes points in an entirely independent, unique direction. That means those little learning nudges never overlap. The result of the swap? It literally doubled token efficiency. So to put that into perspective, 50 trillion tokens suddenly behave exactly like 100 trillion. And that's without introducing a single new piece of text. It's just pure efficiency.
But, scaling Muon up to a massive 1 trillion parameter model was highly volatile at first. The training just kept violently collapsing because this metric called max logic confidence basically exploded. It was too confident, too fast. So how did they fix it? They engineered a gentle mathematical constraint called QK clip. It successfully kept those numbers in a safe range without actually stifling the learning process. The payoff was huge. A flawlessly stable run of 15 trillion tokens with absolutely zero loss spikes. Smooth sailing all the way.
Okay, moving right along to Dimension 2, expanding AI memory.
Older AI systems really struggled with memory decay. They basically relied on a single global dial to forget everything at the exact same speed. But this new architecture, which they call cumulinear, fixes that by using independent memory channels. Think of it kind of like how human memory works. It can retain vital long-term data literally forever, while simultaneously and rapidly flushing out all that irrelevant noise. You remember your best friend's name, but you instantly forget what you had for lunch last Tuesday, right? It's exactly like that.
Which brings us to Dimension 3, the CEO workforce model.
Now, instead of just tweaking the internal math, this dimension completely reinvents how the deployed model actually attacks hard problems. It uses what's called agent swarms. It's essentially a corporate structure. You have a CEO orchestrator that breaks down a complex goal, and then it hands out those specific tasks to specialized subagents. These subagents all work in parallel incredibly fast, and then the orchestrator synthesizes all their rapid results into one highly detailed, rich answer.
Of course, to actually force this kind of behavior, they had to train the AI using 3 very specific reward signals. First, it was rewarded for successfully spawning subagents, which helps it avoid a total serial collapse where it just gives up. Second, it was rewarded for actually finishing tasks, not just making them. And third, for delivering an accurate final synthesis. So what this means for you is, when you hand it a massively complex prompt, it doesn't just act like a single AI anymore. It automatically functions as an entire project team working just for you.
So what's the ultimate result of pulling all 3 of these levers, fusing vision and text?
You see, traditional models usually train heavily on text first, and then they sort of bolt the vision capabilities on later as an afterthought. But Kimi K2.5 used an early fusion approach. They wove vision and text together literally from token 1. This incredible approach achieved zero vision SFT, or supervised fine-tuning. Because of this early fusion, the visual training actually ended up enhancing the model's pure text reasoning. It was able to completely ace visual benchmarks with almost zero dedicated visual training data. That is practically unheard of.
And the craziest part? The Moonshot AI team isn't even stopping here. Yang just previewed a wild, completely futuristic architecture they're working on called attention residue. Imagine this. Instead of the neural network just looking backward through time like they normally do, it rotates to look through its own depth. It's a bit mind-bending, right? But the early tests speak for themselves. They're seeing a shocking 24% token efficiency boost right out of the gate with this new method.
So, I'll leave you with this final thought. If AI can now read depth the same way it reads time, what on earth will it build tomorrow? As developers continue finding these incredibly ingenious ways to shatter the data ceiling, whether it's through radically better optimizers, dynamic linear memory, or massive agent swarms, the true limit of AI is really no longer about how much data we can feed it. It's entirely about how brilliantly we can design its mind. Thank you so much for joining me for this explainer. I'll catch you in the next one.